Alright guys, so today we're going to continue working with absolute value, but today the emphasis is going to be on graphing absolute value and what that looks like. At this point we have a good idea of not only what absolute value does to numbers, but also how we can solve equations. So before we graph our first equation, we're going to take a look at a table of values and just look to see what it does to certain numbers when we take the absolute value. So the first function that we're going to look at is f of x equals the absolute value of x. Alright, just a simple, this is what we call a parent function. It's the most basic form of an absolute value. There aren't any other numbers involved other than just the absolute value of the numbers that we're evaluating. So we're going to take a look at 5 numbers, what that looks like on the graph, and then how we can potentially continue that pattern. So here, when I evaluate f of x equals the absolute value of x, and my x value is -2. Remember, this is where we just take that number and we replace the x. So we're taking the absolute value of -2, which is 2. All right? So as an ordered pair on the graph, this is the ordered pair -2, 2. Okay? We're going to go ahead and fill out the table of values, and then we'll transfer our points over to the coordinate grid here in just a minute. Okay, so we go down to -1. I take the absolute value of -1. I get 1, which gives us the ordered pair -1, 1. Do the same thing with 0. We take the absolute value of 0, which is 0. We have the ordered pair 0, 0. Absolute value of 1 is 1, so that gives us the ordered pair 1, 1. Absolute value of 2 is 2, so that gives us the ordered pair 2, 2. So now we have 5 ordered pairs, and you're going to see a pattern, okay, when we go to put these on the graph. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 1. Okay. Notice that it's starting to form a V, and if we were to continue this table of values, all right, you kind of get the idea here that when we take the absolute value of 3 for x, that we're going to have 3, and then 4, 5. So we can continue this pattern here, and it's going to extend and continue to make this V-shaped graph. All right. Now, with a few of these graphs, there are 2 key features that I want to talk about that are going to help you graph kind of as we go through. One of them is the vertex, and this is just where a graph changes direction. Okay, it's either the minimum, the lowest point on the graph, or a highest point on the graph, depending on what type of graph we are. But essentially, for these absolute values, it's where it changes direction. Okay, and in these first few that we're going to look at is the point 0, 0. Okay, this right here is where the graph changes direction. That's what we call the vertex. Okay. The next feature that we're going to look at is what we call the axis of symmetry. And it is a line that goes through the vertex and also each point, there is a point that reflects across the axis of symmetry to give us another point. So it reflects points. Okay, so for instance, you can look at, there's a point at 1, 1, and the axis of symmetry goes right through the vertex, and then there's another point on the other side of the axis of symmetry. When you look at 2, 2, there's also a point at -2, 2. All right, so these different points reflect. So this general shape right here, this V-shaped graph, all of our graphs are going to look something like this. Right? So we're going to look at if we have negatives, if we have numbers multiplied to the absolute values, if we add, subtract, what that does to the graph and how we can sketch those graphs. Okay. The first couple here that we're going to do, we're going to continue to fill out the table of values so that way you can see the pattern. Okay, and then we'll graph some without the absolute values once we kind of get an idea of what the absolute values look like. So here, this time, our second function, we have f of x equals the negative absolute value of x. So what that means is we are going to take the absolute value of the number first, and then we are going to multiply it by a -1. So the absolute value of -2 is 2. We multiply that by 2, and we get a -2. So the ordered pair is -2, -2. For -1, we have the negative absolute value of -1. That gives us a 1. We multiply it by the -1. We get -1. Here we have the negative absolute value of 0. Right, absolute value of 0, 0. apply the negative, we get 0. We have negative absolute value of 1. Absolute value of 1 is 1. Apply the negative, we get a negative 1. Same thing with the negative 2. Oh, sorry, I don't need the 2 there. Absolute value of negative 2 is 2. Apply the negative, you get a negative 2. All right, so we have all of these ordered pairs that we can use to graph. Oh, sorry, that should be a positive 2. But either way, absolute value of negative and positive 2 is the same thing. All right. So I've got the point negative 2, negative 2, negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 2. So notice here, the graph still gives us a V-shaped, but this negative actually flips the graph or reflects the graph over top of the x-axis. All right, so it's just going to flip it upside down. So one way we can think of this with absolute value is this is kind of like a negative 1 slope, where we have a 1 slope up here where we go up 1, right 1. Okay, our rise over run. Here, with a negative 1 slope, I go down 1, right 1. But the nature of the absolute value is we have that axis of symmetry that reflects those points, right? So it doesn't create a straight line, but instead it creates a V-shaped line. All right. So we're going to take a look at one more. Okay, now this one, we're going to take a look at what happens when we multiply the absolute value by a number. All right, so I've just kind of talked about here where we have a slope of 1, here we have a slope of negative 1. So we should probably have some sort of general idea that this is going to give us a slope of 2, a makeshift slope, right? So let's go ahead and fill out our table of values, and then we'll take a look and see what points we have. So here we're going to say 2 times the absolute value of negative 2. This is 2 times 2, which gives us 4. So I have the ordered pair negative 2, 4. This is 2 times the absolute value of negative 1, which is 2 times 1, which is 2. Right here we have 2 times the absolute value of 0, which is 2 times 0 is 0. Here we have the absolute value of 1, which is 1. So 2 times 1 is 2. And here we have 2 times the absolute value of 2, 2 times 2, which is 4. So we get the point 2, 4. Right. So let's take a look at the graph. Okay, we plot all those points. So remember what I just said about slope, right? How here, the number out in front of the x, that gives us our rise over our run, our slope of 2 over 1. Okay, well, I have a vertex at 0, 0, just like we have all of these before, and I go up 2 over 1, up 2 over 1. Okay, but because of the axis of symmetry, these points are reflected, okay, instead of giving us that straight line. We have the absolute value graph. So this is what your graph looks like. Okay. All right. So let's take a. If you go ahead and flip over to the back, so we've got 3 examples here that we're going to try to graph without a table of values. Okay. So just knowing what the general shape looks like and knowing what's going to happen, how that's going to affect the look of the graph. Right. So first off, all of these first 3 on the back are going to have a vertex at 0, 0. Okay, so that's going to be our starting point. We will take a look down here on example 2 and what happens when you add or subtract numbers and how that affects the vertex and the starting point of the graph here. So notice the value out in front of the absolute value. It's a negative 5. So if you think of this as the slope of the absolute value, it causes us to go down 5 and then right 1. Well, our axis of symmetry goes right through the vertex, reflects this point. We can sketch our graph, and it looks just like this. Okay. And that's your graph for absolute value. Okay. The next one, we have 1/2 the absolute value of x. Okay. Our starting point, our vertex, is still going to be at 0, 0. We have a we're multiplying it by 1/2. So if you think of this as a slope of 1/2, remember slope is rise over run, right? So here where it's a positive 1/2, I can go up 1 over 2, and you can continue to go up 1 over 2 our axis of symmetry allows us to reflect these points. We can sketch the graph. That's your absolute value of 1/2 absolute value of x, or your graph of 1/2 absolute value of x. Let's take a look at one more. Okay, so this one once again has a vertex of 0, 0, and my slope from that point, okay, is a negative 2/3. So we're going to go down 2, right 3. Okay, and then we can reflect those across the axis of symmetry. Okay, and there's your graph for absolute value, or negative 2/3 of absolute value of x. Okay. All right, so now that is if we are flipping the graph, if we are like stretching, if we are compressing it. Okay. Next, we're going to take a look at what happens when we have an absolute value or a vertex other than 0, 0. So everything right now we've always started at 0, 0. Right. So if we go down to take a look at A, B, and C, remember how if we were graphing something in slope-intercept form, y equals mx plus b, the value that we add to the x, okay, that is your y-intercept. Okay. Well, more or less, that's going to somewhat transfer over to absolute value. If you are adding or subtracting a value outside of the absolute value, okay, that's what we do. It says, or we say it shifts the graph up or down. Okay, so where I'm adding a 5, this is more or less going to be your y-intercept. Okay, so we say instead with absolute values, we talk about transformations. We say this shifts the graph up 5. Okay, so it shifts up 5. So our vertex, if we shift the graph up 5, that affects the y value. So my vertex is at 0, 5. Right. My slope, okay, is still the same, up 1 over 1. We can reflect those points. So this is our graph. Okay. All right. Let's take a look at B. Here we are subtracting 2. So this is going to shift the graph down 2, which affects the y-intercept, okay, and puts it at negative 2. The value out in front of the absolute value is still 1. Okay, remember that if there's nothing written there, it's assumed to be 1. So our slope is 1 over 1. Okay, and we can reflect those points, sketch the graph, and there's your absolute value, or your graph for absolute value of x minus 2. Okay. All right. Now, if we take a look at C, okay, this one shifts the graph up 4. All right. So, but notice that this one we also have a negative out in front. The negative doesn't affect the vertex. But remember what we said, when we have a negative out in front, it flips the graph. Okay. So that's going to give us that negative 1 slope, but it doesn't affect where the vertex is. So the vertex is still at 0, 4, right, because we shift up 4. Right, but the negative is going to give us that negative slope. So down 1 over 1. Looks like this. Okay. I've got a couple more. So if we take a look at D, okay, notice D here that we are subtracting 4, but the minus 4 is inside the absolute value. All right, it's not outside. So anytime it's inside, this is actually going to affect the x value of the vertex. All right, and it's a little tricky because it's always the opposite of what we think. All right, if I am subtracting 4, this is actually going to shift the graph right 4 units. Okay, I know it says minus 4, but it's still going to shift graph right 4. So that makes our vertex 4, 0. We affected the x value. We did not affect the y value. So my vertex is 4, 0. I have a slope of 1. Right, there's no value out there, so it's considered to be 1. So I can go up 1 over 1. Okay, reflect those points. You have your graph. Okay. Right. For E, this x plus 3, okay, this is going to shift the graph left 3. So my vertex, we should go left from 0, 0, is at negative 3, 0. Right. We didn't shift it up or down, so it didn't affect the y value. Okay. Our slope is 1, so we go up 1 over 1. There's your graph. Okay. All right, we're going to take a look at one more, and this last one actually has two different shifts. Okay, the minus 1 on the outside, that shifts it down 1, and the plus 2 shifts it left 2. So the vertex for this one, left makes the x value a negative 2, down makes it a negative 1. So we go left 2, down 1. My slope is still 1, so we go up 1 over 1. And there's the graph. Right? So now you guys, you have an assignment that is posted on Pearson Realize. Don't remember exactly how many problems, but you need to go ahead and just use your notes, log on to Pearson Realize, and start that assignment, and you'll submit whatever you have finished at the end of class.